This is the Amp Hour Podcast, released May 13th, 2018. Episode 392. An interview with Matt Duff. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hi, and I'm Matt Duff of Analog Devices.
Welcome, Matt. How you doing?
Doing well.
I think some of our listeners would probably know you from your, I think we've recommended your videos a couple times. I know I have personally. I always recommend your videos about instrumentation amps and everything on YouTube. But you're an analog fan, so we're connected in that way.
Great. I can say that it is a little, so I'll go look at some of my videos and they'll have like 27K, views. Mm-hmm. And then right next on the right-hand side will be one of Dave's videos with like 950K views. So, there is,
Right.
I'm pretty impressed.
Well, you should just try new accents, see if that helps.
Yeah, exactly.
So you've been doing analog a long time. How did you kind of get into the whole world of analog design and working in analog devices?
Well, when I first got out of college, I worked for National Instruments.
Okay.
The folks that make LabVIEW and data acquisition cards.
Mm-hmm.
And I did some digital stuff and some analog stuff, and certainly enjoyed the analog part more. And so then I went back, and after I did that for a while, I went back and got my master's and then joined Analog Devices. So that was a useful, if you're not, married or have other commitments, if you can, go get your bachelor's and work a few years and then go get your master's, I found that really helpful.
You mean actually to get the work experience and then kind of bounce back into the academic world?
Yeah, because then I know when I was doing my undergrad, I was like, that kind of looks interesting, maybe that, but I didn't really didn't know what to take. And then when I went back to grad school, I knew exactly okay, this is exactly what I want to do.
Right,
so
the hands-on stuff that you actually like doing. Yeah.
Yeah.
Well, and I mean, the times when you've been at Analog Devices for a while now. I mean, you've seen not the rise of digital, I wouldn't say, but I'd say the consolidation of analog, at least. I mean, not just on the company basis, but also more and more complex components as well. Have you seen that trend as well?
Yeah, so I would say I started at Analog Devices in 2005, mm-hmm. and I would say, when I joined, there was still very much a performance emphasis. So, we're gonna win by having the best performing parts, and ADI still has that in their bloodstream or that's certainly baked into Analog Devices. But there has been we've been trying to shift toward how do we make it easier for the customer? How do we combine more stuff? Because there isn't, eking out that little extra bit of performance typically isn't a game changer for the customer anymore. Now we need to concentrate more on how to make, improve time to market, make things, get designed faster and that sort of thing.
What was the shift there, you think?
Well, I mean, I think for a whole lot of our customers, you hit to a point where the performance is good enough, and there's there's some Harvard professor with the I can't remember his name, but
Dan Ariely.
No, the Christensen,
the
guy
Clayton Christensen, right?
Yeah, exactly.
Right. The innovative
and so
dilemma.
he talks about exactly, and so he talks about how companies keep innovating, and they hit a point where they have performed, the performance that they've got for their products are good enough, and you keep innovating, but you can't keep getting more value out of that. So I think for a lot of customers, the analog performance is good enough, and so then the question is, okay, what other axis can you innovate on? And certainly trying to do more system type chips and save the customer from having to do all this debugging and so forth. I think that's what we are. There has been a intentional shift to try to work on that some more Analog Devices. Now we still have the components based, and we still are doing high performance components, because those are what those pieces are what these more integrated pieces are built on. And so if you don't keep up with that, then you might get in trouble. But there has been a shift.
Okay. Yeah, that makes sense. I have noticed over the past couple of years as well, the kind of the rising tide lifts all ships kind of thing in silicon, right? Everything has at least a 12-bit ADC these days, whereas that would have been something, not at least, but like it's more common to have higher bit ADCs on standard microcontrollers, and the noise performance is better than it used to be. And it seems like a lot of that is the process improvements, like you were kind of talking or alluding to at least. And now that it's in everything, once you have everything, then what do you how do you differentiate yourself, right?
Yeah, exactly.
Especially,
exactly.
I mean, well, I guess something I've talked about analog devices in the past has been the splitting time with TSMC or other foundry models. Have you noticed that impacting the availability of technologies across your company versus competitors? Like, is there a little bit of seeding of process technologies?
Well, I mean, we do. I mean, I'm not an expert in this, but I just and I should throw out this disclaimer, and I should have thrown this disclaimer out, at the beginning of our talk here, is that I am speaking for Matt Duff.
Right.
These are my opinions.
I think
these are not the opinions of Analog Devices. Right. So, and this is just my view from one seat in the company.
Yeah,
here. Right. So from my view, I'd guess, and this is just my guess, is that kind of half of what we do is from TSMC, and half is our internal fabs.
Yeah. Right, and that was the announcement I mentioned too, is that it was not a complete. It was not that you were giving it up all of it. It was that it was like co-developing new technology with TSMC, I believe.
Yeah. And so certainly they're a huge fab that has a lot, huge amount of fab expertise, and there's some things that it makes sense to partner with them on.
Yep, definitely.
Yeah.
Cool.
But then there's other analog specific processes that we have in-house that nobody else can do, and we'll keep having those in-house to be able to make products that nobody else can do.
Yeah,
so,
right. That's secret sauce stuff that you kind of mentioned as well.
Yeah,
that's great. Okay, and I mean, I guess I'd be remiss if I didn't also mention the just the general consolidation of the industry, right? Obviously, ADI bought Linear Tech.
Exactly.
I'd love to hear how that. Hopefully, that's all very positive news. One of my long-term favorite brands. ADI is another one, of course, but. It was a little bittersweet for me, to be honest.
Right. Yeah. We've heard that a decent amount, and I would say that it's very exciting to have. I think we had a huge amount of respect for linear technology, and I think one of the interesting things. So once we merged, my boss actually a few months after we merged was a guy from Linear Tech.
Oh, cool.
And so we got to kind of compare notes on a bunch of different things, and it's really interesting. You have these two companies, and they're both kind of going after a lot of the same customers and attempting to do kind of the same things. And so it's very interesting to compare notes and say, we tried to do this way, and you guys tried to do it this way. And what did you learn? And what did we learn? And there's this slogan inside the company of trying to be the best of both or whatever.
Right.
And so, hopefully, I mean, I can say at least in my little area, I think we did a pretty decent job. Hopefully in the rest of the company, it's the same, is that, what we have been trying to do is learn from each other and hopefully, try to take on the best characteristics of each. We did a website revamp. So the Linear Tech parts are on our website as of about a month ago or so. And several of the things from the Linear Tech, I mean, I'm sure there are Linear Tech folks out there that are like, ADI website, still not what Linear Tech was,
Oh, well, I was never particularly fond of the website of Linear Tech, but one thing that we will get into is that the circuit design stuff that we'll be talking about, like some of the tools that you work on. I went to the website and I was like, oh, LT Spice. That's supposed to be here. I was like, oh yeah, of course, right. LT Spice and analog. Yeah, that's a very positive thing. There's a lot of good things that came out of it, I'm sure.
Yeah, I think we've been, we were always quite jealous of Linear Tech that they had that LT Spice, and it's a great tool. And I think that we are now super excited to have it. And one of the things that we've been doing on some of our web tools is to export to LT Spice, which we couldn't do before. So now it's a nice, you kind of design it in the web tool, and then you can dump it into LT Spice and they'll tweak it or whatever. And so that's nice.
I will make a callback as well. We've had Mike Engelhart on the show before. And
great.
One of my favorite guests. And, Mike is, well, he's
Mike, right?
He's Mike. Yeah. Yeah. Someone wrote to me on Twitter the other day about being at a seminar too. And apparently there's like, Bodhi plots and switching regulators. I was like, oh man, sounds like Mike's still being Mike. So that's great. Yeah. So that's very exciting. So you've been there for, you said 15 years. Is that right?
Maybe 12 or 13. Yeah. Almost 15.
Okay.
Yeah.
Okay. So prior to the web tool stuff that we're going to be talking about here, what were you doing there?
Yeah. So I was in, ADI has a big site in Wilmington, and I was there in Wilmington for 6 years and worked as an apps engineer, covering precision amps there, mainly instrumentation amplifiers, difference amplifiers, that sort of thing. Yeah. So I covered those. And then my wife's family is from Nebraska and my family is from Texas, and I wanted to move to be closer so that we could just drive to those places. Mm-hmm. And so I was able to change jobs to a job that didn't require touching hardware as much. And so because it was more of a software thing, you can be based in lots of different places.
Oh yeah.
And so I changed jobs and moved to Colorado here. Nice. To do that here.
Yeah, so. That's great. Yeah, and then actually you had written to me and we were talking a little bit, and I was actually out in Colorado I probably drove by you at one point.
Probably so.
As we were chatting. So that was good timing. That's great. That's great. I think you actually stopped into Keithley when I was working there, and I think we chatted at that point, but the main exposure I had to you was through your videos. And so you put early YouTube video, not early, but you were on YouTube doing a lot of whiteboard stuff, and those were really great videos. I really appreciated those. And, what was that experience like? Did you get a lot of feedback on doing those?
Well, the nice thing about videos is that you can see, like in real time, like on YouTube, you can see the views, and so you can see like which videos are getting uptake, and people can comment. So, I guess the traditional way that we get information out there, design information, is we write application notes or we write magazine articles. And so I've done those as well. And it doesn't feel quite as personal, because you go write that and then it kind of goes out in the void, and then maybe somebody mentions it, but it feels like the videos are a little bit more personal. And then also, like, I will now meet people and they'll be like, oh yeah, I've seen you in your videos, where it's very rare for somebody to be like, oh yeah, I read this article of yours or whatever.
Right. I guess it's like a downsampling of information if you're writing an article, whereas a lot of your personality comes through to the video, right?
Exactly. Yeah, exactly.
That's great. Yeah. And I mean, like, tons of great, like, very niche stuff too, like instrumentation amp noise. And I remember, because I think it was when I was working at Keithley, I was just like desperate for info. Like, even, I worked with a lot of great engineers, but sometimes you just need to look up more, and just Googling around and found spectral noise. And I think I forget what kind of calculations I was doing, probably noise floor calculations or something. So really good stuff. Still making videos or no?
I haven't made, so, in my old job as an apps engineer, large portion of my job was answering questions that would come in from customers on various things. And so, you're answering questions and you see trends on what people are interested in. And so then you say, hey, I ought to somehow generate some sort of collateral on this, because obviously lots of people are interested in it. Now I'm doing web tools, and I have done some videos based off of, like, we did this Filter Wizard web tool, and so I did a bunch of filtering videos based on that. But then I've also been working on parametric search tables for the website and improving our infrastructure there and so forth. And there's nothing, like, I can't, I don't think a video about, like, okay, when you hit 300 parts on your parametric search table, it slows down your table, and so you should take these JavaScript, changes to, like, that's probably not very exciting for a lot of people.
It's a different crossover audience, I suppose.
Exactly.
Right?
Yeah.
Not too much JavaScript and deep analog topic crossover there. I guess you're one of them now. It's all about very niche audiences.
Right. Yeah.
Okay. Yeah. Well, I'm sure that we'll I'm sure some of the stuff here. I think that's the other thing too, though. Like it feels like, and maybe you have input on this as well. At least after I left the analog kind of design realm, it felt like there was fewer people talking about analog stuff. I don't know if it was because there was just more readily available end user parts that didn't require as much thinking, or what it was, but I kind of just saw less of it. Is that what you saw as well?
Well, I'm biased because I feel like I am, if you want to work on analog and you had to pick a company in the world to work on it, like it's hard to, I would have picked like Analog Devices or Linear Tech, and now they're the same thing or whatever.
Right.
And so much of what we, that's our bread and butter. And so we're just kind of steeped in it. And so I feel like I'm not the right person to, have that view, because everything that we do is analog stuff.
Got it.
When I was at National Instruments, I felt like, I had a broader view because you could see all this other stuff too.
Right. Everyone's using LabVIEW for everything. Is it LabVIEW?
Right. Well, that's true, right? Yeah.
Yeah. Okay. Well, so let's move into the web tool stuff then. So I mean, so you are obviously you've switched into that role. What is kind of the idea these days? Is it like you're supposed to be able to go to a website and just kind of punch in numbers and out pops a design, or what is the idea there?
Yeah. So you want. We have all of these standard parts, and a lot of parts have been selling. There's still, there's parts that we've done 20 or 30 years ago that people still love and think are fantastic. And what we want to do is make it easier for people to use all of our parts. So as I mentioned earlier, we are attempting to do kind of some more integrated type parts and make it easier to do the full signal chain that way. But you've got to have a big enough market to spend money to do a chip. And once you've done that chip, you're locked into that particular solution. And so there's kind of this in-between area where there are applications that have a decent amount of volume, but aren't enough to make a specific chip for. But you could make some sort of tool or some sort of collateral that allows people to very easily take a few of your chips and put them together and create that thing. And so,
could you give us a tangible example of that?
Yeah. So like, this analog filter design. So we have this massive portfolio of op amps, and there's lots of different analog filters that you could design. So you can design them for low pass or high pass or band pass. You can design them to optimize for noise or low power. You can design filters that are filter at 10 hertz, or you can design ones that filter at 500 kilohertz. And so there's lots of variations, but the theory, I guess, is similar across all of those. And so if you can have a software tool that has the theory and does that theory for the customer, then it makes it easy to design the analog filter. And I know, from past experience, when I had to design an analog filter, you have these textbooks and you have these recipes, and you can follow books and recipes very well, assuming that you have ideal components. But when they break down, when you actually try to use real components. And so the goal of our tool was to show the performance, like show what trade-offs you had with real components, and that helps people trying to do filters. And that also obviously helps ADI because, we put in ADI parts. And so you can see, oh, great, this ADI part works really well for me. Hopefully I'll go now use that in my design rather than, maybe there's an equivalent part from our competitors that would work just as well, but that would take an extra day of calculations for me to figure out. So, I'll just go use the ADI one. So that's kind of the mentality there.
Yeah, marketing through education. That's very common, especially with the engineering crowd, I think.
Yeah.
Okay. And so when you say there's not the wherewithal to build the market's not big enough rather to make a custom part, is that example like making a 100 kilohertz custom Chevy Chev filter or something like that? Is that like the idea of that's the custom thing you're talking about?
Yeah, exactly. So if you knew, like if there was a market for, this 100 kilohertz Chevy Chev low pass or something that was huge, then we would make a chip for it. And you would just, and in fact, Linear Tech actually, has a few chips, and, we've inherited some filter chips
really?
that do.
Okay.
Yeah. So Linear Tech has some chips just like that. So there is a little bit of that.
What are those targeted at? I guess I've never seen those, but I've also never looked for them. You know what I mean? It's like one of those, you don't know what you're looking for until you find it.
Yeah. So, we've got these analog filter products. So if you go to our website, I think they're under what are the analog functions, I think. Yeah. So we got analog functions, and we got these filter building blocks and low pass filters. And filtering is used kind of all over the place. So there's lots of different industrial applications or instrumentation applications. And in general, a lot of the applications aren't that big, but there's a bunch of them.
And so would it be something like an anti-aliasing filter, or is that kind of the idea to have a hard version of an anti-aliasing filter so you don't have to build it each time?
Yeah.
Before
So,
an ADC?
I mean, okay. So filtering is part of, you can filter either in the analog domain or the digital domain. And the reason you filter is you want to clean up a signal. So you've got some sort of the signal that you care about out there. And then there's noise, or there's maybe other interferers. And so you want to somehow just concentrate on that signal. And so you want to do some sort of filtering. And so then the next question is, okay, do I do filtering in the digital domain, or do I do it in the analog domain? And the digital domain has a lot of advantages in that when you filter, it's going to be the same every time. So, analog filters have some variation because they have, component variation.
Right. So like temperature, you're saying, or over time it drifts, or that kind of thing.
Exactly. So that's one advantage of digital filters. And another advantage of digital filters is that you can kind of program it. So, because it's not fixed in your PCB, you can program the digital filter so that on different scenario, so you want 100 kilohertz today and 10 kilohertz tomorrow, you can do that. And so, a lot of applications, it makes sense to do a digital filter, and then you have some sort of fairly cheap and, so a lot of times just an RC filter in the front end to do the anti-aliasing. So no matter what, you have to do some sort of anti-aliasing before your ADC so that you're not, sampling, this higher frequency stuff. If it's beyond your Nyquist, then it's going to come in, and then you can't get rid of it. So you've got to have some sort of anti-aliasing, but normally that can be pretty, inexpensive and not a big deal.
So maybe we should take a quick break here. If someone wanted to find out what Nyquist is and anti-aliasing, and do you have any base level resources that usually point people at?
I don't, and maybe that's a good point. Maybe that's a good video opportunity.
I mean that's the thing too. Is like, so like you were saying with being at analog, right? You've been in it so long, and you see these problems over and over. I at least some of the stuff I've done in the past where I'm like, man, I don't even know some of the words you're saying, right? And it's like, I know these words, but I'm just saying that in other industries, and until you have that vocabulary, it gets so tough. So if there's people listening right now and you don't know these things, Chevy Chev is spelled. No, I'm just kidding. I guess Dave's made some videos about filtering, I guess, and maybe Matt will be here too. So yeah. There are some resources out there, but I guess filtering in general, maybe are you a Art of Electronics fan or other?
Oh yeah, so Art of Electronics is a fantastic book, and I did make a filtering series of videos. There's probably about 10 in the series, and one of them is Chevy Chev versus Butterworth versus Bessel.
Okay,
so you can go look at that.
Yeah,
I don't have anything on Nyquist or anything, but
right.
Yeah.
Right, and I think that a lot of when you get to especially analog filtering, I guess both, but like when I started studying analog filtering, at least it got real math heavy real quick.
Yeah, and that's what we tried to that's a big reason we try to do this tool, is so you don't have to do that math anymore because it's painful.
It is, yeah. Especially because you have to go back through and then recalculate. If you change one thing, it kind of propagates through, and you have to recalculate a bunch of stuff. So that does make it very difficult. But I wonder, how much is so someone starts using the tool today, and they're like, okay, I know I need to filter out anything above 100 kilohertz. Do they need to understand the base level functionality of it, or maybe what is the starting point of someone who is using this tool? Is it still base level analog knowledge?
Well, it's interesting that you mentioned it, because we attempted in the tool. So this is, and I think this is probably a case in a lot of software, is you're attempting to serve both the folks that don't know very much about the subject and make it easy to use. But at the same time, for the people that are the experts, you're trying to put in the functionality that they want. And so I think there's always this tension between those two poles.
Yep.
And so what we tried to do, I think the Chevy Chev Butterworth thing is a good example, is we put in a little slider, and on one side of the slider, it says you can settle fast. And on the others, maybe I should just pull it up here. But there's a trade-off in the slider between, fast settling and the cutoff. So you can use a few stages and kind of have long step response, or you can use a lot of stages and settle really quickly. So we just have a little slider in the tool, and you can move that back and forth. And as you move that slider, it shows you what your filter response is going to look like in all these different views. So the nice thing about a tool is you just go play with things, and you see what,
right. It's like a zero investment way. I mean, that's always a big thing about Spice as well. I mean, I know Bob Peace used to always rail against Spice, but I sure as hell didn't ever create any magic smoke when I was messing around with Spice.
Exactly.
Yeah, so that,
exactly.
May rest in peace. But yeah. Okay. So that's the idea. So where can people find this tool?
So we've got on our website, we have if you go to analog.com/design tools, we have a whole bunch of design tools there. Or for this Filter Wizard tool itself, if you go to analog.com/filter wizard, then you can pull up that tool. And
so not to bring up competition here, but I think I used to rail against the Webbench tool, and I remember that was a National Instruments thing, now TI, and it was like for designing switch mode power supplies. I remember it was super, super, super simple, and I used to hate it because it was just like, it felt very kid-like, and it kind of felt like Lego, almost not Lego, but like Little Tykes, it felt like. And there was only I think some of it was the web technology limitations as well. And I remember like giving this feedback to National, and they're like, okay, thanks for that. And then I talked to someone else, they're like, oh yeah, I love that. And it was because for me, I was looking to like dig in and really, get into the data around, the different types of inductors and all of the, the buck versus boost, and like actually see waveforms and stuff I was used to in Spice, where someone that was coming in and they were just clueless. They're like, oh, well, like, here's the answer. And it's just like a couple options, and I just want the answer. I just want this function at the end of the day. And I think that is kind of what you're talking about as well, of the beginner versus the more advanced thing.
Yeah, exactly.
So which does it err on for you?
Well, what we try to do is we try to make it, we start off with this idea of, okay, we're going to make this tool really simple for the beginner. And so that we can, with very, in a couple minutes, you can get to the answer and you can see stuff, but you don't have to know much about the theory. But then what we also try to do in the tool is add, we have these little question marks with kind of explanation of what we're doing.
Tooltips, yes, I know those.
Yeah. And we have a whole bunch of different views, and that you can see, like probably your beginner is probably not going to care about things like group delay and phase delay, for example. But so you can go through the whole tool and never look at those. But we have those in the, there's a little pull down, and in the pull down, you can see those. And the same thing, like later tabs in the tool, you can see the noise response. And so a beginner probably doesn't care about that, doesn't have to look at it. Right. But for more advanced engineers, that noise where we show the noise performance and where it comes from, I think they get really excited by that. And so that's how we've tried to make kind of the default mode really simple and straightforward. But then if you go click on some, ring control or some control, you can dig down and get more expert advice. So that's been our way we've dealt with it.
Okay. Yeah, that's great. Yeah, I'm clicking through it right now. And like you said, it's the filters, analog.com/filter wizard, right?
Exactly.
Yep. Okay. And I mean, at the end of the day, it is popping out a circuit. What do you expect people are going to do with all this? I mean, like, just go and build it? Is that kind of the idea?
Yeah, so we've got at the end we have a little eval board system, so it's not like it magically populates the eval board for you. So it's just a blank eval board, but we, based on what you've chosen, we say, okay, you should have these little PCBs, and then we give you a BOM at the end and say, okay, here's your BOM, here's your eval board. So you should be able to just take these things and solder it up, and then we also export to Spice. So if you want to go, if you don't trust our tool and want to go try it out in Spice to make sure that, it works the way that you expect, you can do that. Or a lot of times what people will do is they'll want to tweak it a little bit. So they'll want to add, let's say, a passive filter in front or behind the tool. Yeah. And so, when you put it in Spice, then you can do whatever you want. And so that's kind of the next step is you go simulate in Spice, or you can go filter. You can go build with an eval board, or you can just take the schematic. You have a schematic, and you can go take that schematic and put it in your design if you want.
Right. I mean, Matt, it seems like your career has been like trying to get fewer people to contact you about asking you questions about how to do things. Well, first it was videos. You're like, well, I could just do this once, and then you don't have to explain it to people anymore. Now it's like, I just make a tool and people just do that instead of calling me.
Well, the name of the game, I don't know about you, Chris, but like when I was working, there were some times where I would have to contact the semiconductor manufacturer, and I'd be like, do I want to do this because it's going to be this, I'm going to have to wait a day or two.
3 days, yep.
Yeah, and then probably they're going to come back with some more questions, and I got to ask them questions. And man, I wish I could just find this on the web. Let me spend an extra 10 minutes, and maybe I can find this somewhere on the web. And so I hope that I'm kind of meeting the needs of those folks, because at the end of the day, what we're trying to do is make it so that people can ship their product faster. And whatever we can do. And I guess I want to give a shout out to people that are ADI customers, let your sales guy know, or use the feedback mechanisms that we have on the web. If there's areas where we can make your life easier and make it so that, you can get your product out the door faster, like we want to do that. So, tell it, we're always kind of trying to, okay, what can we do? So, if just let us know. That'd be great.
Right. Well, around here I talk about chip printers, but that's still not a real thing. So that's just a joke thing.
Maybe one day.
So how much does it matter, I guess? So okay, so people are going through this tool, right? And I mean, I like it at the beginning. It's low pass, high pass, band pass. That's just kind of high level filter types. And then it's actually picking how many poles it's going to have and the topology. So if it's Chevy Chev or whatever Butterworth, how much does that end up mattering to the customer? Is it? I mean, it really is just a. Is it just a reordering of components, or, I mean, how much should people care about learning the underlying technology there?
Well, I mean, I would hope. I mean, the hope for the tool is that most people don't have to learn the underlying technology. So the hope is that, you put in kind of what you want, and then the tool through these different views shows you what you can get, and you look and you say, hey, that's good enough for me. Great. Let's use that. Certainly if you want to understand how the tool works, you can dive more into kind of how that works. But, we've got this, like we have this little optimization control where you can optimize for power or noise. And based on that, we pick your components for you. We pick your op amps for you. But again, kind of going back to this novice versus expert thing, there were a lot of people that said, hey, I don't want ADI to pick the op amp for me. I have particular op amps that I really like or that I have in stock, and I want to go use those. And so we have a mode where you say it's the I want to choose mode, and in that mode you go and you pick your own op amps, and then the tool shows you based on the op amp you picked, here's the performance you're going to get, and maybe it's good or maybe it's not, or and the other thing is, I think I just want to show you the performance rather than trying to pick something for you, because there's some people let's say maybe you have a filter that you only need 20 dB of rejection. Normally a filter, when you're doing some sort of active filter, you'd want 60 dB or, something relatively substantial. Yeah. But, maybe your application only calls for 20. And so if you have a design that would look pretty crummy to me, but if that's all that you need, then it allows you to avoid having to stock a new amplifier, then fantastic.
Right.
So
that is the engineering trade-off. Oh, look,
Yeah.
I see you have different resistor series as well, because that resistor series, capacitor series, because that basically determines how hard the component will be to get, right?
Exactly.
Yep. Okay. This is great. Yeah, this is really nice, actually. Is there is there a control for cost?
So we haven't, and I guess that's always a debate as to internally. So, part of this is you're saying, okay, I'm targeting at the customers that don't want to spend a lot of time. So they're probably doing kind of lower volume. So you have these super high volume customers, and they can spend, 6 months of some engineer's time just to optimize a filter or whatever, And so those guys, they're going to care about cost to the nth degree because they're shipping millions of parts or whatever.
I mean, that's really what their job is too, is to do those optimizations on the small level, right?
Exactly.
Yeah.
But then you have a whole lot of customers that, they're shipping, hundreds or thousands or whatever. And their main thing is time. Like the development cost is the biggest part of how much this thing is going to cost going out the door, rather than, a little extra on components. And so that's kind of what this tool is targeted at. And so kind of internally, the question is, we have thought about like, hey, should I put a lower cost thing in? But then you put the lower cost thing in, and then you give a design that's maybe not quite as good, and then the customer has problems with it, and then so I don't know.
Yeah, I mean that's the thing. Like a small trade off at the beginning. If you use like a 1980s era op amp that you guys still make, then that might work, and it might be super cheap, or it might even be available elsewhere. But there also might be some weird corner case thing like phase inversion or whatever, right?
Exactly.
And then you don't realize that until you're 6 months down the line, and it's like, oh, well, thanks a lot, Matt.
Right.
Have you gotten that yet? Have you gotten a thanks a lot, Matt, in a negative voice, or mostly just positive voice?
I think we've done, fortunately, phase inversion doesn't really affect filters.
That's true.
And that, as long as you're using the voltage in the kind of the operating range of the part, and part of, what the tool does is it shows you, here is the voltage range of, there's a view that shows you here's the voltage range that you're going to get. Yeah. So we have it, and we've attempted to build in stuff that we expect people to run into problems. So like a real common problem with the Allen key filter configuration is that when you're doing a low pass filter, at some point the low pass filter stops being a low pass filter and starts going up again. So you'll see this low pass characteristic, and then at some point, all of a sudden the line turns around and just starts heading up again. And
that's not
so
what I wanted at all.
Exactly. And so we know that that's a potential problem, and so we built into the tool, and that's based on this interaction of. So what's happening is that the signal is kind of going around when it starts going up again, your signal is going around your amplifier. So it's no longer going through your amplifier. And it's caused by this combination of what the output impedance of your amplifier is and what your components are. So, and so we've built that into the tool so that, like, let's say you picked your favorite op amp, and your favorite op amp actually has a high output impedance, then you'll see that upward going slope in the view, and hopefully at that point, rather than when you've actually built it, you'll see, I don't want to do that,
Mm-hmm. Okay, well, let's bring this back to kind of the target audience for this thing. I mean, where are you seeing people I mean, this I guess is a very broad question, but where are you seeing people implement filter designs these days in like modern applications? Is it?
Yeah, so kind of going back to our digital versus analog thing.
Yeah.
So the digital filters have a lot of advantages, but the big disadvantage is that you have to digitize everything before you can use that digital filter. And so you need a relatively expensive ADC. So, ADI is happy. Like, you want to do a digital filter and use a relatively expensive ADC, ADI sells a lot of really nice ADCs. So go to it. That's fantastic.
Right. But you're also going to be doing that in order to then throw away a bunch of those samples or otherwise you wouldn't necessarily need that, you're saying.
Exactly. So filtering is reducing information. And so if you can reduce the amount of information that your ADC needs to sample, that means you can either sample slower or you don't have to have such a wide dynamic range for your ADC. And so if you can do the filtering before your ADC in the analog domain, then a lot of times you can get away with like a 12-bit ADC or some, much less expensive ADC. So I think in the modern era, that's a big reason that you would use an analog filter. Another, if you're doing kind of, let's say 500 kilohertz type filter, you may also be putting some load on your digital back end, and you'd have to up your FPGA, or you'd have to up your microcontroller. And so that's potentially another reason, is to save you work in the back end there. And then some people just don't want to mess with the way companies are structured. Maybe you've got an analog engineer, and then you've got the digital engineer, and the digital engineer is fully booked, and the analog engineer has a little bit extra time. And so, you can use the analog engineer, and they design a filter, and then that saves the digital engineer from having to do this extra work. So that's actually a valid use case too.
I've never heard of that one actually, but yeah. I could see company culture for sure. I mean, some people just, it's all the way we've always done it, right? That's a very common refrain. Okay. So a lot of, I guess I think about like audio, industrial, I guess video, but that's pretty high bandwidth to start with, right?
Yeah. So above kind of, I don't know, 5 megahertz, say, you don't want to use the active filters kind of peter out. So a lot of times you'll still use you won't use a digital filter, you'll use a filter that has like inductors, and, instead of using amplifiers to do the thing that inductors do, you just use inductors. So that's typically what you do at the higher frequencies.
Okay. So this is a lot of sensor processing and such to really to get that signal in the range you want it to in the first place, right?
Yeah, a lot of industrial instrumentation type applications.
Yep, that feels like home to me. Okay, that's great. So what are some of these other tools? So you've worked on this one. Obviously, this is kind of a focus of yours, but there's other stuff in there. I mean,
So like an example of a tool that we're doing right now. So we did this tool a few years ago, the filter tool.
So this has been around for a while.
Yeah, so this has been around for a while.
Okay.
It's been around for a few
years. I've been out of the
years.
game for a while. Okay.
Yeah. So a tool that we're actually working on right now is this ADC driver tool. And so if you want to go to it's actually still in development, and we have a little area for tools that are still in development that we call the playground. If you go to playground.analog.com, it kind of lists tools that are in development there. And one of the tools that's in development is this ADC driver tool. And when you're doing not so much, these ADCs that will be in microcontrollers, but if you're doing a higher end ADC, like a 16-bit ADC, driving that ADC is kind of tricky, because you have to have a driver that's powerful enough to drive it, and then you have to set this RC filter in between, and then it goes in the ADC. And if you do things like set the resistance of the RC filter too high, then it increases your distortion for your ADC. If you set it too low, then your amplifier can't drive it. And so there's these various trade-offs. And so what we're doing now with this tool is try to create a tool where you can go do these trade-offs. And I think a lot of it is based on, you get this nice ADC, and maybe it doesn't consume very much power. And then now you have to drive the thing, and you have to have a driver that consumes just as much or more power than the ADC does itself.
Right.
And so depending on what you're doing, maybe you can get away with having an amplifier that's maybe a quarter of the, so in the data sheet, we put in the best amplifier to drive that ADC. So if you use what's in the data sheet, then you'll get, the performance the data sheet says. But the best amplifier maybe consumes a ton of power.
Right.
So in your application, maybe there's a few specs that you can, you don't need as much. And so we created this tool to allow you to play around with different things.
Okay. That's great. And so, I mean, maybe could you talk a little bit about the theory of why you need a driving amplifier in the first? I guess you kind of touched on that, but like, why do people need amplifiers there in the first place for these higher end ADCs? So
an ADC is based around the switch capacitor design, and so what you have is a little capacitor, maybe 20 or 30 picofarads, and it samples on that capacitor, and then internal to the ADC, it does all this charge redistribution to determine what the value is. And so what's happening is every sample period, you're plopping this 30 picofarad capacitance on the input of whatever you're sampling, and that has to settle within the tiny sample period that you have allowed. And so you need, you can't just like put a sensor there that has, I don't know, 50K, 10K ohms of impedance there, because there's no way that it's going to be able to drive that capacitance to 16-bit settling in that short sample period.
Got it. So it's like if the 30 picofarad capacitor is like a very, very tiny bucket, you're trying to see how much water you could fill up into that bucket. Is that kind of the idea?
Yeah. So you
without splashing.
Right. So you can imagine that you have this bucket, and you've got to fill up the bucket, and your water level is the top of the bucket, and you have to get to whatever 1/65,000th of the close to the top of the bucket in this really short time period. And that's very difficult to do if you don't have something that's actively like trying to push the water into the bucket.
Right.
So,
right. Yeah. Oh, okay. So it's not actually, so it's only doing 1 bit at a time though. That's the idea?
Well, you have to, if you're buying a 16-bit ADC, yet you're only settling to 14 bits by the time that you actually sample, then you're wasting a lot of money, So you have to get settled to the accuracy of the ADC that you're purchasing. And so that's why.
Yeah. I was just asking because you were saying the filling it all the way up to the top of the 30 picofarad bucket. I thought it was you're filling it up to a percentage of whatever the percentage is of the overall input range. So if the you're filling up to a percentage of the input range, but you want it at this exact point. Oh yeah, right.
And so you have to fill it up to just that exact point. Right?
Yes, I see what you're saying. So so if the 30 picofarad bucket represents 1 volt total, and you have a half volt, you need to hit exactly. Oh, you're saying, that's the 1/65,000.
Exactly.
Is you need to hit it with to the
that much precision,
50000, whatever the precision number is. Yeah. You got to hit that within nanoseconds, milliseconds, microseconds. I don't know.
Yeah, a lot of
sampling rate.
Yeah, so a lot of times these are 100 kilohertz ADCs or 500 kilohertz ADCs. So that's kind of the so you've got you've got a few microseconds there, but then a lot of times the you don't get the full, like the ADC architecture itself says, out of that, let's say you're sampling at 500 kilohertz or something. So, in theory, you would have 2 microseconds. But in reality, the ADC architecture says, sorry, buddy, I'm taking 1.5 of it for my stuff, and you get 500 nanoseconds to do the rest, So,
those ADC designers, man.
Right.
Yeah.
So that's always an internal.
Right, because I guess the water's got to flow back out of the bucket on the other side, right? That's
exactly. Yeah.
Yeah. That's. Sorry about all the water analogies. I'm sure there's some old analog engineer out there listening, being like, "It's not like water." It's just the easiest way we could talk about it, right? It's this tough. Okay, this is great. And I mean, what has been traditionally difficult about? You said it was because of the. Oh, you were saying because the specific amplifier that's suggested in the datasheet might be over spec for what people really need. So this kind of helps to figure that out.
Yeah, exactly. So if the amplifier that's in the data sheet works for you, like if the package size and the price and the power consumption and the precision of the amplifier, if those are all fine, then use that, because that's the part that's recommended to make this ADC shine. But there are a lot of people that come to us and say, for whatever reason, I don't want to use that amplifier that you guys are recommending. What else can you tell me? And then we're like, well, it's real complicated, and it'll take you 3 days to figure out. So
first do 30 years of analog design, and then have a cohort of others who have also done that, and then you can talk about this cogently.
Exactly.
Awesome.
Exactly.
Okay. Well, you should sell that. You should sell 30 years worth of design.
Yeah.
I would buy that. I would totally buy that. Wow, these are some fancy ADCs too. I'm looking at so you can actually switch out which ADC you're actually targeting, and boy, they don't get any cheaper, do they?
Yeah.
I do remember some of the stuff too. One of the things that was always difficult for me was when it was a differential amplifier versus a single-ended. That always kind of threw me off too. I know that there's parts that drive differential versus single-ended amplifiers, and you could do that conversion from single-ended to differential. But I would just follow the data sheet too. I would just be like, okay, well, I just got to buy another part here, and that makes it what I need.
Yeah, exactly.
So this kind of does help to allow more options, you're saying?
Exactly.
Cool. Okay. Are there other things you can introduce? Like I can see the drivers are inverting, non-inverting followers, so you could actually invert the signal if you needed to as well.
Yeah, and so I guess we've got in the upper right hand corner there's this little give feedback thing, and as I mentioned, this is in development, so we're still adding features. Got it. One thing that we're debating is like, okay, what should we add? When do we say this is finished, and so forth. So we're really looking for feedback from people using the tool to say, I really want this, or why are you doing an AC driver tool at all? Actually, I want this instead. Stop wasting your time. Whatever. If anybody's listening to this and wants to go try this out and give us feedback, we would love to have it, because we have the ability. So that's the thing about software, is that unlike hardware where you're constrained, you try to tweak this thing and then it makes this other spec worse. With software, you can just keep working and make it wonderful, but then the development cost for this free tool goes out the roof. And so
you've also noticed that software developers aren't cheap. Okay.
Exactly. So the whole goal behind all this stuff is to sell more ADI parts. That's how I get paid.
Yep.
And so at some point we have to say, okay, I don't think any more work is going to sell any more ADI parts, so let's move on to the next thing. But that's always a tricky thing to determine where that cutoff is. So
right. What are some of these other tools in the playground here? So the playground.analog.com, I see mixer spur graphical representation. I also see RF frequency gigahertz, so I'm already like, this isn't for me.
Yeah, so that mixer spur tool actually came from Hittite. So we talked about how ADI, LT and ADI merged a year or two ago, and before that we acquired Hittite, and this was actually a tool of theirs. And so,
what is Hittite?
And it's they were an RF company, so they specialized in a lot of high frequency stuff, and so they had this tool on their website, but it was Flash based. And so we, so we converted it to JavaScript, but we never, the part of the point of the playground is let's put some stuff out there, and sometimes stuff doesn't graduate. And I think this is maybe one of those that's not going to graduate, that's out there for people to use. But I think we said, okay, based on what we can tell of how much interest there is in this tool, we're not going to move forward to. So I was actually just asking, I don't know what a mixer spur is. Do you know what that is? So it's for, we sell a bunch of these mixer parts, these RF mixers,
like an RF mixer. Okay.
Exactly. And as you use these mixers, you create all these various spurs and frequencies maybe you don't want. And so the point of this tool is to actually show you where those are. Now, what I don't understand is, it gives you, you hit calculate and it gives you this very, colorful plot. Yeah. And, I am no RF guy. So we basically copied a lot of the information that it was already in the existing tool. So our mandate was like, okay, make it like the existing tool. So we're like, okay, got it. I'm not quite sure what we're doing here, but it works like the existing tool.
The lines line up. Yay.
Exactly. Okay, good. And so that's kind of where this tool came from.
This sounds like exactly what I would do, because I'd be like, I don't know what that is. I need to get more RF guests onto the amp hour, apparently. I'm really confused. What about other tools on the website? I mean, like, there are a bunch. Are you doing other, so like power management stuff and
so we have there's the LT Power CAD, which I can't say that there's another group that's from Linear Tech that's doing the LT Power CAD, but that's kind of, it's a tool to allow you to design these switching regulator circuits and again, kind of adjust various characteristics of that. So that's a downloadable. When you go to our site, we have these little icons. You see the little cloud, and that's a web thing, and you see the little arrow, and that's a Windows installable tool. Yep. So the LT Power CAD is a Windows installable tool. You mentioned earlier, I've got a video out there about instrumentation amplifier common mode range, and you know, the fact that the inputs and the outputs, what you can do can vary with the gain and with the, you know, the supplies and so forth. And sometimes it can be a little difficult to figure out. And so we've got this instrumentation amplifier diamond plot tool where you, instead of having to go read those cryptic graphs that are in our typical performance curves, you can just put in your specific characteristics for your instrumentation amplifier. And then the tool says, hey, this doesn't work, or this will work, or this doesn't work, but by the way, here are these other 4 amplifiers that would work for you. And so again, the goal is to make it, instead of having people have to sit and think, you just put in your stuff and bam, there's your answer. And, you know, again, hopefully, you know, that's less time that the customer, you know, I keep saying customer, that I mean, there's like, you know, I'm sure there's lots of people listening that like, well, that's me or whatever, but
right.
You know, our goal is to make your life easier.
Okay, well, I have a request for you then.
All right, great. Tell me.
I did not think of this beforehand, Matt. I want you to fix data sheets. Why in the hell are data sheets PDFs? This is something that I used to talk to people about at SupplyFrame, my old job, like, what the hell? So, like, you're talking about, like, oh, you don't have to go look at the chart, right? But currently, and maybe this is changing, but, like, so there's no way to trace on top of characteristic curves, right? So, like, if there's, like, if there's something where you have a 3.3 volt, you know, power curve, and you have a 5 volt power curve, but for some reason you're operating at 4 volts, there's no way to, like, to interpolate between them other than, like, you know, pretty much guess and check, or even just like to move my mouse along a characteristic curve. No one publishes their numbers, right? There's no, like, interactive charts. I'm sure this has been done before, but I want, here's what I want, Matt, and I want you to do it because Analog is probably going to buy all the other companies anyways. I want a standard data sheet format. I want like why isn't there a charting tool for all characteristic curves, you know?
All right, so you got that playground.analog.com up, right?
Yeah. Are you going to show me something that I'm happy about now?
Go to, well, I don't know. I mean, this is why we have this stuff up, so we can get feedback on it.
Yeah.
So go to the sixth tool down that says Performance Gallery.
Okay, yeah. Okay, Performance Gallery. And we will link many of these things. I mean, we'll link everything in the show notes, but yeah. Oh, okay. All right.
Okay, so then this is kind of, the goal is to have interactive typical performance curves. And so you can go, you know, mouse over stuff, see stuff. You can zoom in. We have some filters where you can go, you know, see various things. So I don't know. You might look at it. Yeah.
Okay, but I need this for every data sheet that you guys make.
Yeah.
For the past 40 years.
Right. Yes, exactly. So that's the tricky thing. And you know, I think there is a little bit of hesitation. You know, so you said, hey, why don't you interpolate between, you know, so when we characterize a part, we characterize a part under certain conditions. So,
of course. And this is, you're about to explain exactly why this doesn't exist yet. And I get that, but go ahead.
Yeah. That we do have a little bit of concern, you know, so let's say we take temperature measures and said, I don't know, 25 degrees C and 85 degrees C. And that's what we've got. Well, you know, theoretically you can kind of linearly interpolate between the two, but in reality, we don't know how the part exactly performs at 55 degrees.
If 57 degrees, there's some weird anomalous behavior, and you wouldn't have known about
that. So that's one concern. And then, you know, the other concern, like, I think this is quite feasible going forward, but then, you know, kind of to your point about all the parts going back 40 years, you know, the guy that did that part 30 years ago is no longer with ADI, and, you know, the little engineering paper or whatever that he did, you know, like, that's no longer in some file drawer, and you know, so so
I get it. I'm just saying this is what they make interns for. I'm just saying, you know, there's a lot of kids up the street at well, I guess you're in Colorado, but what ADI is out in Massachusetts. MIT keeps graduating new people. I'm just saying.
So again, if you're listening to the show and you go try this Performance Gallery and you like it or you don't like it or you have other things, we've got that little feedback thing. So just, you know, like, we're driven by what people are saying we ought to do.
Okay.
And so
how much feedback are you getting these days? A little bit, a lot of it?
So we get, like on the tools that are more popular, we get, I don't know, a fair amount of, so maybe some feedback every week or something.
Okay, so that's not that much though. That's
yeah, it's not. So
what I'm saying though is, if someone is using this, is good, and this is good for our listenership. If you are listening and you have feedback, you'll be a squeaky wheel, and Matt will probably do your bidding. I'm just saying.
Exactly.
Or his minions will.
Right. So not much for minions. So yeah, exactly.
Well, maybe you'll get more minions. You need to get more minions.
That's right. And especially if somehow you can say, if I had
I'm
this,
a customer, right?
then I would buy these parts. But since you don't have it, I might have to go to this other guy.
Yeah, no, I think this is kind of pointing out too, right? So I'm guessing that when you started at ADI 15 years ago, you probably wouldn't have guessed that you'd be working on web tools now, right?
No. Yeah.
And I'm guessing the same. Like, I never would have thought that actually would help to sell more parts. But at the end of the day, like you started saying before, is like, this does help people get their job done faster. There's tangible value here. So that makes a lot of sense. Cool. Well, I'm now on the ADA 4522-2, which is an op amp, and I'm looking at zoomable charts. This is very Web 3.0. I gotta say. Is that what? Right? I don't know what web version we're on.
I don't know either. Yeah, but it's got all the it's got the fancy JavaScript. So one of the things that we do a lot in our tools is we try to have the tool run a decent amount in your browser.
Yeah,
because for anything that runs in your browser, you don't have to have this round trip to the server and then back again.
Yes,
and so hopefully it's nice and snappy.
Yep, and I like that too, because it's, during the days I'm usually on a Mac, and at night I'm on Windows or Linux, and like web-based stuff is just a little bit more cross-platformy than like sometimes I'll even, with all apologies to Mike Engelhardt, sometimes I'll use the Falstad simulator because LT Spice doesn't, it works on Mac, I know that, but like not that great, so yeah, sometimes it's just easier to have a web tool. So yeah. It was interesting before the show too. You were mentioning what was the thing you were saying about books between the web?
Right, yeah. So the pace at which the web technologies are evolving, so it's amazing. So we as I was mentioning to Chris, I did this filter tool and all the electrical engineering theory. Like, I had all these books that were from the 1970s, and
that stuff has not changed much. You're saying,
yeah, the stuff hasn't changed much, and so I could use a lot of these books from then. And then I ordered some books on the JavaScript and the web technology, so I could get up to speed on how that stuff worked. And I realized relatively quickly that was just a dumb idea, because by the time the books were printed, the stuff was out of date already.
Yep.
And so you really just have to go to the various websites and learn directly that way. And so I think that it is interesting what you can do now versus what you could do just 5 years ago in terms of web technology.
Yeah, it's great. It's great. What do you? I mean, on the electronic side of things, are you seeing any trends in the analog world that people should keep an eye on? I mean, changing ADC specs, or process tech that's making op amps change characteristics wise, or? I mean, I guess you're seeing more on the website these days.
Yeah, I mean, I would say that, like, in my little wheelhouse, I see a lot of kind of the web technology, but I see, unfortunately, because I'm not, unlike what I was doing 7 or 8 years ago, where I was interfacing directly, answering customer questions all the time. Mm-hmm. Now I'm more on this web technology, so I'm probably not the best guy to ask. The only thing I know is that we are driving. How can we figure out how to make folks' lives easier? Mm-hmm. And that's like we're having to force so what ADI wants to do, what ADI's DNA is let's make better products. I want to make the next that's what everybody really wants to do, is like, just let's do this new exciting thing and get this extra few dB of SNR or whatever.
Yeah, right.
And I think we are having to be disciplined in saying, look, if we release this product, it may not sell as well as we want, versus some other product where instead of doing that, we so maybe the next product we do, and we're actually working on, we've released some of these products that the ADCs are easier to drive. So the vector that we improved was not the ADC performance itself, but that it was, now you can use these very low power op amps, and you can see some of these in that ADC driver tool. Mm-hmm. You can use these low power op amps to drive these new ADCs that we have that you couldn't do before. Yeah. And we have another line of parts where we've integrated in the amplifier with the ADC. So now you can just connect an amplifier straight to it, and you don't have to worry about that. So
it's almost like the feature is that the data sheet's getting shorter almost.
Yeah.
Well, I guess just less complicated, not necessarily shorter, but like just that there's less caveats, that there's less need for measurement because more is taken care of for you.
Yeah. So the hope is, before you needed 3 parts and 3 different data sheets, and now you just need 1. Yeah.
Yep.
So,
yep.
Yeah.
Are you seeing that on so I remember there was an ADC part that was like a all-in-one sensor chip type of thing with like a ARM processor on it, and one of the versions even had like a little, I think, Bluetooth radio or something. I mean, does that end up impacting the tools that you're working on as well, or no?
So normally what we try to do the tools that we focus on is we look for some sort of problem that a bunch of customers, a lot of times a bunch of smaller customers have. So like if there's a problem that a couple of vertical customers have, then we don't bother with that because we have sales guy. We're just going to support them directly. And so, anything the massive customer says, we just say, yes, sir, whatever you would like, sir.
Please just keep paying your bills.
Right, exactly.
Yes, so I too have worked with the oil and gas industry.
So when we do a tool, we try to find something that hopefully spans a bunch of parts, a bunch of problems that, maybe these, customers that aren't these massive customers have, that we can make pretty graphs out of it, that has hopefully a lot of math because computers are really good at math. Mm-hmm. And so those are kind of the characteristics. So if you have if you've released a part that is, this one kind of complicated part, it may not be worth trying to develop some sort of web tool around that one particular part.
Got it. Yeah. These are all like self-service tools here, right? This is trying to help the customer help themselves versus the expensive part. Then the application engineer helps that person because that's what they're there for.
Yeah. And there's a total another. So the kind of tools that I work on are kind of more when you're first looking at whether you want to buy a part and you're trying to evaluate, this part versus another, you're trying to kind of build up, what's this little circuit block going to look like? And so we do these web tools because there's very low barrier to entry and so forth. But then there's another part of the company that works on drivers for particular parts, so that, when you buy your ADC, you have some sort of driver so that you can get it up and running, and so the low level, so I'm doing these web tools, but there's other folks that are doing some example microcontroller code to make it easy that way. And so I would imagine a part like the one you mentioned, somebody there is making microcontroller code so that you can easily interface to it.
Yep. Yeah, that makes sense. And that's a common thing in the micro industry specifically. Yeah, I think. But it wouldn't necessarily be a visual tool like you're saying. It's that's just a quick start resource type thing.
Yep.
Awesome. Well, Matt, anything else we should know about it in analog devices or around the analog world that you see these days?
Oh, I'm sure there's if I had looked at my I'm sure there's a lot of stuff that the corporate guys would say that I ought to be pitching, but I don't know. So I'd say that's all I know. So
that's good. Yeah, we'll hold you to that on that one here. That's good. All right. Well, where can people find you online?
So I know that lots of folks are out there on Twitter. I actually am just lurk on Twitter. I don't actually have an account there. So the
he only follows the Amp Hour. He follows the Amp Hour Twitter account, nothing else. That's
right. Exactly.
Yep,
exactly.
Yep.
So I'd say that the two things that you could do is, one, on our tools themselves, we have this feedback thing. Please use that feedback. And on most any page on the Analog website, in the lower right, there's a little triangle. Sometimes you miss it, but you can click on that little triangle and you can give feedback that way. And it may seem like it's going into a black hole, but we do actually read that stuff.
It's going to Matt's inbox. Yeah.
Yeah, exactly.
Go to analog.com and click the button and then say, hi, Matt.
Yeah. So that's definitely one way. And the other way is you can just contact me directly at matthew.duff@analog.com. That works great too.
All right. Well, thanks, Matt. I mean, thanks. I really did appreciate all the videos you made over the years, and it sounds like you're still making lots of useful things. So I appreciate that, and I appreciate you coming on here to talk about it.
Oh, thanks for having me. This has been fantastic.
Okay. Well, we'll talk to you soon, and we'll look forward to trying out your web tools.
Okay. Thanks.